Good morning, students. In the last lesson, we have studied about the different types of indicators. Natural and synthetic indicators on the basis of color change and olfactory indicators on the basis of smell. Today we will learn about a different type of indicator, a very different indicator from the previous one, that is universal indicator. And in order to understand the universal indicator, we should have a clear concept about pH. And in order to understand the importance of pH, first we will study about the neutralization reaction in which the product is salts. We will start with the universal indicator, the last indicator that we have to study. And this is completely different from the previously one indicators that we have studied. It has an advantage over those indicators. And this indicator is commonly used in our laboratory. Why? We'll get the answer. Because this indicator measures the relative strength of acids and bases. It does not only tell us about whether a substance is acid or basic, but it will measure the relative strength of acids. If we are having two acids, one is dilute sulfuric acid and other is acetic acid, it will tell us, this universal indicator will tell us that which among them is strong and which among them is weak. So this indicator gives us idea about the strength of acids and bases. In order to understand it better, we should have a concept about pH scale. How does this indicator works? This indicator works on the base of pH scale. So pH scale, first of all, what is pH? As we know that aqueous solution of water has contained both H plus and OH minus ion. Why? Because water is an ionic compound. It is a polar molecule. It is an ionic compound. So in aqueous solution, some H plus ions and some OH minus are in free state. That's why if we add the acids to a water solution, H plus ion and concentration get increased in acidic solution. And the concept of H plus and OH minus was given by Arrhenius, the scientist Arrhenius. This is an Arrhenius concept that when we add the acid, the water solution, acidic solution will have the H plus ions. If we add the bases, then bases release the OH minus ions according to Arrhenius. And we have already seen in the previous chapter that after dissociation, bases release the OH minus ions. So in a basic solution of water, we will see that OH minus ions get increased. There will be a large amount of OH minus ions, but still H plus ion persists in the solution. So H plus ions are both present in both acidic as well as in basic solutions. And utilizing the H plus ion concentration, the scientist Peter Lawrence Sorensen has invented a term pH. pH is a German term. pH stands for P stands for potence. Potence means power. H stands for H plus ions. So pH stands for power of H plus ions. It tells us about the H plus ion concentration. But what is the relation between pH and H plus ion concentration? pH is inversely proportional to the H plus ion concentration. pH is the negative logarithm of H plus ion concentration. What does it mean? It means that if we are having a large amount of H plus ions in a solution, pH is very low. So utilizing this H plus ion concentration, the scientist Lawrence Sorensen has devised a pH scale. In 1909, he introduced a pH scale which having a number 0 to 14. 0 to 14 tells us about the H plus ion concentration. This number is based on the H plus ion concentration, and this number represents the acidic and basic strength of solution. This is the picture of pH scale. As I told you that Sorensen has given a number from 0 to 14 on the pH scale, and pH has a inverse relationship with H plus ion concentration. So with increase in every number on the pH scale, H plus ion concentration get decreased. So on 0, H plus ion concentration is maximum, and on 14, H plus ion concentration is the minimum. According to Lawrence Sorensen, this pH scale gives us a relative strength of acids and bases. How? He gave the 7 number, or we can say that 7 number is given for neutral substances. Neutral substances have a pH value exactly 7. Neutral substances like pure water, distilled water, or sugar solution or salt solution. If we take this solution, pure solution, and test it with the pH scale, then this solution will completely lie on 7 number. So 7 number is given for the neutral solutions. 0 to 7 is for the acidic solutions. So on the pH scale 0 to 7, on the pH scale, it means that testing substance is an acid. And 7 to 14 is numbers are for bases. Those number represents the bases. If a testing solution lies on any number beyond 7 till 14, it means it will be a base. And one more thing, as we studied that H plus ion concentration is decreasing from 0 to 14. So H plus concentration is maximums on 0. It means large amount of H plus ions means a strong acid. When we move to one number, H plus ion concentration get decreased. Further decrease. On moving from 0 to 7, acidic characters decreases. So we have to take acidic character decreases. So strong acids will lie in between 0 to 3. Weak acids lie in between 3 to 7. 3 to 7 in between. Basic characters get increased on moving beyond 7 to 14. So weak bases lies in between 7 to 11, 7 to 10, and weak strong bases lie in between 10 to 14. This is the universal indicator. Universal indicator paper will lie on the pH scale. What is universal indicator? Universal indicator is actually a blend of different type of dyes. Different is a mixture of different dyes which gives different colors on pH scale. Universal indicator is a mixture of different dyes, different indicators, many different indicators which gives different color on pH scale. So it is a universal indicator paper over the pH scale. That's all for indicators, universal indicator. Now we'll take the neutralization reaction. What are neutralization reaction? When an acid reacts with a base, it will give the salt and water. What happens that during an acid and base reaction, when we add an acid to a base, this acid neutralizes the basic character, and on vice versa, this base cancels out the effect of an acid, and we get a salt along with water, and this is the neutralization reaction. What happens in neutralization reaction, that as we know that base consists of OH minus ions and acids consist of H plus ions. So both these ions combine together to form the water. And the below example, in this example, if we recall the examples of base alkalis which are water soluble, these were metal hydroxides or ammonium hydroxide. In case of metal hydroxides, when a metal hydroxide or a base reacts with a mineral acid, strong acid, HCl, this NaOH is also a very strong base, and HCl is also a strong base, strong acid. If OH minus and H plus ions combine together, what is left here? Na and here Cl. So these both combine together to form a salt. This is the case of neutralization reaction. In neutralization reaction, we get a salt along with water. So we will study more in detail about the salts. What are salts? Salts are the products of an acid and a base. Examples: zinc sulfate. In order to name the salts have two parts. The name of a salt have two parts. First part is derived from the base, and second part is derived from an acid. So in case of zinc sulfate, we make a conclusion that it has been derived from an hydroxide of zinc hydroxide, a base. It has been derived from a base, so base may be zinc hydroxide, metallic hydroxide. And in case of sulfate, sulfate word is given to those salts which have been derived from the sulfuric acid. So in case of salts, sulfate salts will be formed from sulfuric acids. Chloride salts will be formed from HCl, hydrochloric acid. Nitrate salts will be formed from nitric acids. In the same way, carbonate salts derived from carbonic acids, and so on. Salts are mostly solids, as you have seen at your home. The most common example is sodium chloride. These are solid crystallines, rigid in shape. Salts have high melting and boiling points. Their salts have high melting and boiling points. Usually, salts are soluble in water. You can easily make the solution of salt in water. But some salts does not get dissolved in water. As salts are ionic compounds. For example, in case of sodium chloride, sodium is a cation and chloride is an anion. So it is a combination of ions. So salts are ionic compounds. Because of their ionic properties, they are made up of cation and anions. They will lose the ions in solution and conduct electricity in solutions, just like acids and bases. Acids also conduct electricity in solution, bases also conduct electricity in solution, and the same way salts also conduct electricity in solution because they are ionic compounds. They will generate the free ions in the solution. Salts of strong acids. Now we'll take the conjugate salts. So salts of strong acids are sulfuric, nitric and hydrochloric. And a strong base. Strong bases, sodium hydroxide and potassium hydroxide. When strong acid and a strong base combine together, we will get a neutral salt. We will get a salt which will be neutral on pH paper, which will give the pH value 7. When a salt of strong acid and weak base combine together, here which one is strong? Acid. So the salt will be predominated by acid. So the salt will be acidic in character, acidic in nature. The salt of a strong acid and a weak base will be acidic in nature. It will give the pH value less than 7. Salts of strong base and a weak acid will be predominated by the base. So that will show the basic character, that will show the basic nature, and its pH value will be more than 7. Now we will understand the importance of pH in our daily life or in the normal functioning of organisms. As we know that different parts of human body have different pH levels, and our body works best at slightly alkaline pH. Why? Because the pH of blood is slightly alkaline, and that is in between 7.35 to 7.45. And this slightly alkaline medium is very essential for the proper functioning of a human body. Slightly alkaline pH of blood. But if we see that in case of digestive system, pH value ranges from extremely acidic inside the stomach to the slightly alkaline in saliva pH. Because pH of saliva is slightly alkaline, that is in between 6.5 to 7.5. And we have already studied that pH of saliva is essential for the breakdown of carbohydrate. So the medium of mouth is slightly alkaline, and that medium is also good for the health of our teeth. Whenever the medium of the mouth gets altered, if we eat the sugary foods and the leftover or the residue of the sugar then acted upon by bacteria, and then that will produce an acidic medium inside the mouth. Residues of sugar will lead to the production of acid inside the mouth, and when there will be an acidic medium about 5.5 below 5.5 acidic medium, it's very harmful for the health of our teeth. As we know that our teeth are made up of a very strong material, that is calcium phosphate. It's the very hardest material. But we have studied also the corrosion process by acids. So that strong material can also be corroded by excess acid. and that corrosion of the enamel is lead to tooth decay. That's why it is advised to clean your mouth or rinse your mouth properly after eating any food material, especially after eating sweetening agents, in order to maintain the pH of your mouth, because pH of the mouth, maintenance of the pH of mouth is highly beneficial for the health of teeth. On the other side, we see that pH of upper stomach is slightly acidic. It is about 4.0 to 6.5, but the lower stomach have mildly or have strong acids, strongly acidic. Lower stomach part is strongly acidic, in between 1.5 to 3.5. Because of the release of hydrochloric acid inside the stomach. Hydrochloric acid is released from the lower stomach. That's why, because of the presence of hydrochloric acid, it is highly acidic. Lower part is highly acidic. As we know already, this acidic medium is important for breakdown of proteins and killing of bacteria. But sometimes it happens that excess of hydrochloric acids gets building up inside the stomach, and that is not good. You feel uneasiness, you feel uneasy, and in order to neutralize that acid, you will take antacids like milk of magnesia. And if this condition persists a longer time, and it will become a daily routine that excess of acid starts building inside your stomach, that will lead to an extreme condition. Excess of acid building inside the stomach will lead to ulcers inside the stomach. So there should be a proper concentration of acids inside the stomach. So importance of pH also lies in maintenance of the environment of stomach or maintenance of your body. On the other side, we also see that pH is also used by certain organisms, plants, animals, in a form of self-defense mechanism. Honeybees will inject an acid into your skin, methanoic acid into your skin, when you get a stung. Honeybee's tongue will inject formic acid into your skin. In the same way, a plant called nettle, it is here in texture. The leaves of the plant nettle is here in texture. If you touch the plant, that plant also inject formic acid into your skin, and you will feel a burning sensations. You will feel a burning sensation. That's why your mother give you a remedy if you got a sting from honeybee, to neutralize that acid with baking soda. The self-defense mechanism of wasp is different. As honeybee injects the acid into your skin, wasp injects bases into your skin, strong bases into your skin, and that can be neutralized by vinegar. So whenever you get a sting from wasp, you can neutralize that sting with vinegar. So there is a difference between the sting of honeybee and sting of wasp, and both these ways are used by these organisms as a protection, as a defense mechanism. Importance of pH is also exhibits in soil medium. So plants thrive best in a neutral, in slightly neutral soil. If the medium of soil gets highly acidic or highly basic, then the retardation of growth of plants will occur. The plants will have a very bad effect of highly acidic or highly basic medium on their growth. That's why pH of a soil is a very important characteristic which decides the optimum growth of plants. So here we have seen the importance of pH in the survival of human beings as a defense mechanism in the optimum growth of plants. It is also important, pH is also important for the survival of aquatic animals. When there will be an acid rain, that acid rain will increase the acidity of a lake, and those plants or animals which thrive in the lake environment will be affected by that. Fishes will not survive at acidic environment. Fishes will die out at acidic environment. So acidic rain have a very negative or a bad effect on the survival of organism. So pH of soil, pH of lakes, pH of human body is also or is very essential. That's all for today. In the next topic, we will take the chemicals, commercially important chemicals which are obtained from sodium chloride.